Alright, now that we've gotten to the point where we have graphed um, linear equations and we have actually solved linear equations and written equations for linear equations, we can get to the point where we can start talking about what happens when we have linear inequalities. Alright, now a little bit of misprint on the front of this particular slideshow right here. It should say linear inequalities, not linear equations. Now, objectives again, basically the majority of this is going to be graphing. There's not going to be a whole lot to this section. We have to graph linear inequalities, and we'll talk a little bit how to solve problems and what the solution sets for a particular linear inequality actually means. Alright, just some key vocabulary words. Obviously, linear inequality is going to be the big one because that's what we're talking about. Boundary line. Essentially, a boundary line is going to be like a line when we graphed, but it's going to, I guess, have a little bit of a different purpose this time around. Okay, so essentially with linear equations, we just graphed a line, and any point that happened to be on that line was a solution to our equation. Right? We're not really going to do anything that's a whole lot different this time around in terms of graphing. We still have to graph an original line, but what you will notice as we go through this is the fact that we no longer just have an equal sign after the y. Alright, we're still going to be in slope-intercept form when we graph. As you can see, I have a slope and I have a y-intercept right here. But I'm going to be using inequality signs, which means that not only might we include some of the points that happen to be on our line, or in this case it's going to be our boundary line, but we also happen to have an infinite number of other solution points that could possibly make our inequality work. Alright, so the key with this is we have to make sure that we're getting our boundary line graphed first. Okay, now this is an example of what's going on here. Now, essentially, our boundary line that is shown to the right is 2x minus 4. Alright, we have our y-intercept right here at negative 4. We use the slope of 2 up 1, 2 over 1 to find points that happen to be on that line. Okay, now, the line itself in this case is not necessarily a solution to this particular inequality. Right, what we're looking for is, in the first case up here, is our answers or our values that make this work have to be greater than that line. Okay, that would be represented by the area up over here, the area kind of shaded in blue. Alright, on the other hand, our boundary line also separates us from solutions that happen to be less than that particular line. Okay, that would be represented by this greenish looking area over here. Okay, so the line itself helps divide things out, but what's going to happen with an inequality is the fact that if we're talking about y being greater than 2x minus 4, any point that you would pick from this top region here would make that particular inequality true. On the other hand, if you look at the green inequality down here, if we want values of y that are less than 2x minus 4, any point that we pick over in this region is going to make that true. Now in this case, because there is no equal to part associated with our inequality signs, anything that happens to be on the line itself is not going to be a solution of those, but we'll explain that a little bit more as we move forward here. Okay, now here, if we would happen to, and this is just an example of what would happen if we did put an equal to aspect in there, we'd still be looking at solution points being in this region up here. However, what we would also include or bring in is the fact that any point that happens to be on the line, anywhere on the line, would also be a solution to that inequality, because it can also be equal to, as you can see on the bottom here, equal to that particular line or graph. Okay, now when we use symbols, basically what's going to happen is we're going to graph a boundary line. If you have a less than or equal to sign or a greater than or equal to sign, your line is going to be solid, all right, which indicates that points that are on that line will actually be solutions to the inequality we're looking at. If you just have a less than sign or a greater than sign, technically you're supposed to fill your line in as dashed. And the reason for that is it's still a boundary line. It still divides us from the region that gives us solutions and the region that does not give us solutions. However, anything that would happen to be on the boundary line would not be a solution to the inequality. So if you were to pick a point off that dotted line and fill it into your inequality, it would not make it true. All right, moving forward, we're just going to start with something basic and simple here. There's not a whole lot of work that's required with this particular inequality to start with, because as you can see, it's already in what we could still refer to as slope-intercept form. All right, I have a y-intercept, which would be +2, so I can go ahead and put that on my graph. And then I have a slope, which is -1/3. All right, so I can go from that point down 1 and back to the right, not back to the right, or over to the right, 1, 2, 3, to get a point that's on my boundary line. Or I can go up 1 and now back 3. All right, remember again, the whole idea of a negative slope is this can represent -1/3, or it can also, -1/3, or it could also represent 1 over -3. All right, now because I don't have an equal to part in there, the line that I make, or the line that I fill in, has to be dashed or dotted. Okay, now I'm not done yet because I have to shade the portion of my graph that's actually going to represent this inequality. Okay, now the way that I like to think about it is if you have a greater than sign, you can always think about there is a top side and a bottom side, or an above and a below to your line. In this case, the above our line would be up here, so I would shade in the region above the line. Okay, if you struggle with the whole concept of above and below, you can always pick a test point and see whether it does or does not, make your inequality true. If the test point makes the inequality true, that means it is part of what should be shaded on your graph. If it is not, then it tells you that the other portion or the other side of your line should be graphed. So a good point to always pick is 0, 0, because it's the easiest thing to fill in. So if I take my original inequality up here and I fill 0 in place of the x and the y, so 0 is greater than or equal to -1/3 times 0 plus 2. Okay, well this is just going to simplify to 0, so I end up with 0 is greater than 2. Now, we can all tell that 0 is not greater than 2, so that tells you that the point 0, 0 is not a solution to the inequality. All right, well 0, 0 would happen to be down here, and as you can see, based on how we already shaded, that would make sense because 0, 0 lies in an area that does not represent our solutions, or it basically lies in the unshaded region of our graph. All right, here's another example. Now, if you remember back to when we first started talking about linear equations, if you had y equals something, it represented a horizontal line. Okay, it's no different in this case. I have y, and it's not equal to, it's less than or equal to, but it's just set equal to, or I guess I should say on the other side, it has just a number. All right, so if it's y and a number on the other side, it's still going to be horizontal. All right, so what I'm going to do is I'm going to go to -1, which would be down here. All right, and I'm just going to fill in a couple points here to get my line started. All right, but this is where my horizontal line would happen to be. Now, because I have the equal to aspect here, or think about it, because I have this underline right here, that means that my line has to be solid. All right, so I'll get that drawn in there. Okay, now again, solid line just means that any point that would happen to be on that line will be a solution to my inequality. All right, now the above and below idea is pretty easy in this case because it's just strictly a horizontal line. So I would be shading anything that happens to be down here. Now again, we could check if we wanted to. Again, I'm going to pick 0, 0 as a test point. Now in this case, there's no x to fill into, so the only thing I could fill into would be y, and 0 is less than or equal to -1 would be what I get. Well, 0 is not less than or equal to -1. So my test point up here tells me that that region, well, that particular point does not work. So that region is not going to have any of my solutions, and that's why I shaded below the line. All right, now here's an example of something that's a little bit more complicated, okay, because it's not written in slope-intercept form right away. So we got a little work to do before we can actually graph what's going on. All right, so the first thing I would want to do here is I would want to distribute my 3/4 through there. Actually, no, I'm not going to distribute my 3/4. You could if you wanted to. There's essentially two ways to start this. Instead of doing that, I'm just going to take this 3/4 and I'm going to multiply both sides by 4/3 to get it out of there, make things a little bit easier. So over here, this is essentially going to simplify or reduce to 1. So I'm going to be left with 8x minus 2y is greater than or equal to. Now on this side, technically, remember, you're multiplying by a fraction, so think about the number there as also being a fraction. All right, 6/1. What I can do here is 3 actually goes into 6 twice, and that would simplify that 3 to a 1 on the bottom, or they're both, the 6 and the 3 are divisible by 3. So I can reduce before I multiply. Now I just multiply across the top, and I would get 8. And on the bottom I would get 1, so I don't actually have to write that. Okay, remember, solving for y, I want to get in slope-intercept form, so I'm going to subtract 8x from both sides. So I'll be left with -2y is greater than -8x plus 8. All right, now one step away here, we have to divide by -2 to get the y by itself. Now remember what happens, and I'm going to divide everything by -2. What happens when you divide by negative? You have to change the order of your inequality, or basically switch the direction of your inequality sign. So I'm going to make this a less than. -8 divided by -2 is +4. X 8 divided by -2 is -4. All right, so I get my inequality. I have a y-intercept. I have a slope. So y-intercept. I have a slope. I can graph a boundary line using that particular information. So I'm going to go down -4 on the y-axis, get my y-intercept, and then I'm going to use the slope of 4 to graph 2 more points to give me an idea what my boundary line is going to look like. So I'm going to go up 4, 1, 2, 3, 4, and I'm going to go over 1, or to the right 1, because it's +4/1. And then I could also go down 4, 1, 2, 3, 4, and back 1. Just, if you wanted to keep going from the top point we put up there, that would be perfectly fine. I just wanted to make sure that you understand the slope. 4 is the same as 4/1 or -4/1. Now, I could draw my line in. We don't have an equal to aspect to my inequality, so it's going to be a dotted line. And I will draw in the best dotted line that I can. Okay, now, the concept of above and below still kind of holds true in this case. If you look, the above portion would kind of be up around the second quadrant on the left side of it a little bit. The bottom idea would be to the right and below. So in this case I'm less than, so I'm going to shade over here. But again, just to kind of test that theory out, if I would fill 0, 0 in, 0 in for the y and 0 in for the x, I would get 0 is less than. 4 times 0 would be 0, so -4. So 0 is less than -4. And again, 0 would be right here. It's in the non-shaded region, and it didn't work when I filled it in down there. So that just proves that I shaded in the correct area to begin with. Okay, this just kind of talks about the whole idea that we've been using before on the previous couple graphs. When you're done, if you're not sure about where you should be shading, pick a test point. And 0, 0 is always the easiest test point because it essentially cancels out a lot of different terms that are in your inequality to begin with. Okay, now just remember, when you're thinking about solutions to inequalities, any point that happens to be in the shaded region is a solution to the inequality. Anything that is outside of the shaded region is not an equation to the inequality. Okay, now this also talks about using intercepts to graph. x-intercepts, y-intercepts. I'm going to run through that real quick here, because when you have some numbers that maybe aren't necessarily real great to work with in front of your x and y terms, intercepts tend to provide an easier way to think about this. So if we're talking about x-intercepts, remember, if you're trying to find your x-intercept, you fill 0 in for the y. Okay, so I'm going to put 0 in here. So essentially that term falls out. So 3x is less than or equal to 12. I would divide by 3, and x would be less than or equal to 4. Okay, or essentially, if I filled in 0, I got 4 out. Okay, so I filled in 0. Excuse me. I filled 0 in for y. Okay, and I got 4 out. So essentially I have 4, 0. That would be something that's on my line. 4, 0, which would be over here. Now, don't let the fact that you don't have an equal sign throw you off. Even if you would have, in this case, even had this been like x is just less than 4, you filled in 0 for y, you got 4 for x. It's still going to be on your boundary line. You just have to remember that had we not had the equal to aspect to the inequality here, your boundary line would just consist of a dotted line, not a solid line. Okay, so the idea of finding x and y intercepts is essentially the same. So I'm going to go ahead and find the y intercept now. So I'm going to fill 0 in for x, 4y less than or equal to 12. Again, this cancels out, so 4y is less than or equal to 12. Divide by 4, and y is going to be less than or equal to 3 in this case. So I filled 0 in for x. I got 3 out. So the point 0.03 would be right there. Now again, we started with less than or equal to, so that means the line that I should be able to get from those 2 points will be a solid line. So I'll draw that in. Okay, and we said using intercepts was kind of your way to cheat. You don't necessarily have to find 3 points if you're using the whole intercept idea. Alright, so I got that. I have a solid line because I have the equal to or the underline down here on my inequality sign, and less than would be below the line. So I'm going to think about it right in here. Again, going back, if I look at my original equation here, and this would actually make things easier if it's in this form. If I pick a test point of 0, 0 in this case, which would be in my shaded region this time around, if I put 0 in for x, 0 in for y, that whole side is going to end up being 0. So 0 is less than or equal to 12, which actually does make sense. So that just tells me that I shaded, or the point from which I drew my solution, or my test point, is where the solutions are supposed to be. Okay, now we're going to talk about applications here for a second. Just one application. It's going to be relatively easy. Just kind of showing how you can actually use inequalities to solve some word problems. Okay, so essentially in this case here, you have a carnival that charges $4.50 for adults and $3 for children. The school needs to make at least $135 to cover expenses. So X is supposed to represent the number of adult tickets, Y the number of child tickets. Write an inequality that represents what's going on. Okay, well essentially if they have to make at least $135, we know that whatever we have that represents our tickets has to be greater than or equal to 135. Okay, at least meaning at least that number or more. Okay, well X is supposed to represent adult tickets, so I'm going to say $4.50 times X plus $3, and you wouldn't necessarily have to put the dollars in there if you don't want to, times Y is going to be greater than or equal to 135. Okay, so this is going to be the inequality that represents how many tickets would have to be sold in order to get at least $135. Okay, now on the bottom here it says if 25 child tickets are sold, how many adult tickets must be sold? We'll get to that here in a second. But essentially to solve that, we would take the 25 and we would fill it in place of the child tickets, and we would solve for X to figure out how many adults would have to be sold in order to get the same thing. Now on the next page here, we were supposed to graph the inequality. Graphing this is going to work essentially the same way. Now this is a good example of a problem in which you have some numbers here And even the 3 is not the worst thing in the world, but you have larger numbers. Using intercepts might be a better idea to graph this. So what I'm going to do is, x-intercept wise, 4.5 x plus, I'm going to fill 0 in for that y, 135. Okay, so this would give me my x-intercept. So 4.5x is going to be greater than or equal to 135 because that other part essentially falls out after everything's said and done there. So to solve the rest of this problem, I have to take and just divide both sides by 4.5 to figure out what the x-coordinate of my x-intercept is going to be. Now again, don't worry too much about the inequality sign rather than equal sign. And I'm going to get 30 here. Okay. Now that just represents the fact that my x value of 30, so I would go over to 30 on the x-axis, and then I'm going to go up. Well, actually, no, I'm not going to go up because it's 0 that I filled in for my y value. So that's going to be 1 point that helps me with my graph. Okay. Now I'm going to do the same thing, but in place of the x this time, I'm going to put 0, and I'm going to figure out what my y-intercept is. Okay, so essentially here, my whole x stuff is going to fall out. So 3y is going to be greater than or equal to 135. And if you take 135 and divide it by 3, you're going to get 45. Okay, so I filled 0 in. I got 45. So our graph, and I'm not really worried about this a whole lot being straight. That's not too bad. Okay, that's going to represent essentially what my graph is going to look like. Okay, now you'll notice how we only have the positive x and y coordinate, or the first quadrant up here, because when we're talking about sales, it wouldn't make any sense to have a negative number of tickets or a negative dollar amount that we're going to have going on there. Okay, and remember from before, the question asked how many adult tickets would have to be sold kind of to break even or get to that 135 if you sold 25 student tickets. So if I have 4.5x representing the adult tickets plus 3 times, so we're going to sell 25 student tickets. I get 4.5x plus 75. It's less than or equal to 1, or excuse me, greater than or equal to 135. Okay, I'd have to subtract 75. So let's see, 135 minus 75 should give me something in the region of, I don't know, let's see here, 35 minus 75. Oops, struggling here. Probably should be able to do that in my head. 60. Okay, so 4.5x is going to be greater than or equal to 60. So if I divide by 4.5, 60 divided by 4.5 is going to give me roughly 13.3. So that would mean I'd have to sell 13.3 adult tickets along with the 25 student tickets. Now, you can't sell a third of a ticket, so we would probably need to round that up and say 14. And if you look at what's going on here, you could probably tell in this region right here, 25 child tickets would roughly be around this area. And if you go down, that's pretty close to 14. All right, so you can see where they match up there, and you get your whole idea of what's going on. Now again, not too difficult. You just need to be able to understand how to use the graph and how filling in different values is going to affect what's going on. Okay, and remember, anything, and I kind of drew up here my graph a little bit, but anything that would happen to be, in this region over here, as far as adult tickets, child tickets combinations, would help us reach that 135. Anything that would fall short, kind of down in this region down here, below the line, would not make it work, and we'd end up losing money on the entire situation. All right, homework, just like usual. If you have any questions, please just make sure you ask. All right.